let's talk about space food. In the early days of space exploration, food was mostly squeezed out of tubes and brought up in dehydrated packets. But today, we can have quite a variety of food. There's all sorts of things that we normally consume on Earth that we have here in space. We just need some minor adaptations. In the case of sandwiches, we had to substitute for bread, so we decided to use tortillas. But why? Mostly it's because bread, of course, makes crumbs. When you eat them on Earth, the crumbs fall down to the ground. But here, crumbs are just going to float away. On the other hand, the tortillas that we use are heat treated and specially packaged in an oxygen-free environment to prevent mold from growing. They're packed in packages like this. And thanks to that process, a tortilla like this can be good for 18 months. So what we're going to do is we're going to open up our tortilla, we're going to get our peanut butter, squirt it onto the tortilla, get our honey, squirt that on there, and we will have a peanut butter honey sandwich in space. Open up the tortilla, and voila, a weightless tortilla. Okay, we got one tortilla. Whoa, got away. Take my peanut butter, open it up. Can't rip it. Fortunately, we have space scissors. They're attached via tether so they don't go floating off. Take the scissors, cut open the peanut butter pouch. Peanut butter's open, squeeze it onto the tortilla, carefully. And now a little honey. Hey, I noticed something cool about the honey. Instead of the bubble sitting up at the top, because there's no gravity to make it float up, the bubble is floating in the middle. Okay, all closed up, and the envelope of peanut butter and honey is ready to eat. Not too bad. Last piece of my sandwich. It's been pretty delicious. Well, my hands are all sticky. Gotta clean up. We don't have a sink. We don't have running water. Gotta wash yourself up some other way. Disinfectant wipes. All cleaned up. Nice and hygienic on the space station. This goes in the trash. Lunch is over. Delicious.
Only a thin atmosphere encircling our planet holds all that we need for life on Earth. Outside that bubble is the cold vacuum of space. It is an environment that is hostile to human life in numerous ways. People traveling and working in space do not need an Earth-like environment simply for comfort. It's actually a matter of survival. Humans have orbited Earth, flown far into space, landed on the moon, and returned safely to our planet. Now, we're aiming to put a human, not just a robotic machine, on another planet for the very first time. Scientists believe we now have the technology to send a group of astronauts to Mars and back. This will not be a typical week-long mission for space shuttle astronauts, nor will it be a few months, as experienced by astronauts in the International Space Station. Astronauts going to Mars will be gone for 2 to 3 years. Space is a vacuum with no air or water. It also contains many hazards for the spacecraft and its occupants, including the damaging effects of cosmic rays and solar radiation, and the risk of being hit by meteoroids. There's no atmosphere, so temperatures can range from unimaginably cold in the shadows to extremely hot in the full sun. The gases in the atmosphere that keep us alive on Earth, they don't exist in space. Neither does the pressure of the atmosphere, which helps to regulate our heartbeats. Long trips in a confined living space may also lead to psychological problems. Can you imagine spending every minute of every day with one person for 2 years? Now, imagine spending that 2 years in an enclosure not much bigger than a typical classroom. Stepping outside for a breath of fresh air is strictly prohibited. Before astronauts can travel to distant planets in our solar system, there's much to be learned about how the human body adapts physically to living in space. A particular problem is living in microgravity. Recall from earlier studies that gravity is the force of attraction between masses. On Earth, gravity gives us our feeling of weight. Microgravity is the condition in which the gravitational forces that act on mass are greatly reduced. For example, a person would weigh only 1/3 on Mars of what he or she would weigh on Earth. That's because on Mars, the force of gravity is weaker, only 1/3 than on Earth. In space, that person is almost completely weightless, as are the spacecraft and all of its contents. In conditions of weightlessness, the body undergoes many different changes. Bones have much less pressure on them than normal, and so they expand. The heart does not have to pump as hard to circulate blood. Muscles, used for walking and lifting, do not get used as much, and therefore weaken. Even a person's visual depth perception is affected. These and other concerns will be extensively studied on the International Space Station in preparation for interplanetary travel. When walking or working outdoors on Earth, we usually try to dress appropriately for the conditions, wearing a warm jacket if it's cold, and rain gear if it's wet. When taking a walk in space, however, we would be faced with a more difficult environment. Once astronauts leave their spacecraft, everything they need to survive must be brought with them. So air, water, a heating system and a cooling system, even a portable toilet. Also, the suit must be flexible enough to allow the astronaut to grasp a wrench or to twist a bolt. Each spacesuit is custom designed for the man or woman who is going to wear it, right from the size of the shoes to the size of the gloves. Outside Earth's atmosphere, none of the life support systems that humans must have for survival exist. If people are planning to move out to space colonies in the coming years, their space station homes will have to come with several important features. So first, there must be clean water. There needs to be breathable air, as well as comfortable temperatures and air pressure. They all have to be provided. As well, the station must carry its own source of power to provide the energy necessary to run the life support systems and other equipment at all times. The International Space Station will be using devices that can recycle almost 100% of the water in the station. This includes wastewater, water used for hygiene, as well as moisture in the air. Careful recycling of water on the space station will keep a crew of 7 people comfortable for several months. Recycling is also essential in the day-to-day life in a space station because there's so little room for storage. As much of the materials carried as possible have to be recycled or reusable. Consider, for example, the challenge of how best to use the limited supply of water carried in a spacecraft. Researchers have developed the technology to filter, purify, and recycle the same water again and again on a very long space flight. This technology is now being used here on Earth to provide environmentally safe sewage treatment for houses. On the International Space Station, the environmental control and life support systems are designed to ensure life support. The functions of the life support system include things like recycling wastewater, which includes urine, to produce drinking water, using recycled water to produce oxygen, removing carbon dioxide from the air, filtering microorganisms and dust from the air, and keeping the air pressure, temperature, and humidity stable. Scientists have also come up with a simple but effective way of producing oxygen in space. As you may recall from past studies, the process of electrolysis uses electricity to split water molecules into their component elements, hydrogen and oxygen. Applied in a spacecraft, this process can supply most of the oxygen that a crew needs. The hydrogen is vented into space.